S average, which is equal to, so in between the ratio between the peak load losses to the off peak load losses. So this is for the what? The load and losses characteristics, a curve. Okay. Now we need to calculate. So the small t and capital T. Okay. So the capital T, it is for total time period, total time taken by the load, or total time taken by the losses. Okay. Right. So a small t, which is nothing but a 0 to t, 0 to small t, which is on time. Okay. Which is for on time, and small t to capital T, which is for off time period. Okay. Right. Now every load have same corresponding losses. So each and every load, the load, it may be an peak load, or load, it may be an average load, or load, it may be an off peak load. Okay, off peak load means what? It is not a peak load, but the load is there. Okay, you don't think that there is no load. Okay, off peak load in the sense, it is not a peak load. Okay, it is not a peak load, but the load is there, right? Fine. So every load have some corresponding losses in the above load curve. The peak load and off peak load having corresponding peak load losses and off peak load losses, right? So we need to go for the derivation. So load factor, we know that load factor. What is the load factor? Average load divided by peak load. Okay, it is a definition, we already discussed it, right? So average load divided by peak load, right? So average load, P average divided by peak load. You see here, P average is average load, peak load is in P2, right? So you mark it here. So FLD, which is equal to P average divided by P2 from the load characteristics. Okay, right. Now we need to calculate the average load. Okay, how to calculate the average load? See, the average load, I already said that the, what do you call? So the peak load plus off peak load, peak load plus off peak load. So the, what is the peak load time interval? 0 to t. What is the off peak load time interval? T to t. Okay, so like that we need to calculate here. So P average load, okay, P average load, which is equal to, okay, so P2, here you see that P2, from P2, how to calculate the time interval? 0 to t. Okay, so the P2, t minus 0, P2, t, this is a maximum end, so t minus 0, P2 into t minus 0, right? Plus. So what is next one? Off peak load. We need to calculate off peak load. So the off peak load in the sense P1. Okay. So P1 into the maximum value is capital T. The small value is small t, right? So initial value. So that T minus small t, right? Divided by the total time. Why? Because we need to calculate the average value. So the total time T. So P average, which is equal to, from the graph, P2 into small t minus 0 plus P1 capital T minus small t divided by t, right? So now substituting this equation in the first, okay, what is the first equation? Load factor. So the load factor, which is equal to P average divided by P2. So we know that the value of P average here. So we need to substitute here. So FLD, which is equal to P2 of T. Why? Because P2 into T minus P2 into 0. Okay, it may be a 0 and plus. So this is as usual T minus T. Why? Because we don't know the value of capital T and small t. So we can know that value, then we need to substitute here, right? So the formula FLD, which is equal to P2 of small t plus P1 of capital T minus small t divided by total T divided by P2. So rearrange this one. FLD is equal to T small t divided by capital T plus P1 divided by P2 capital T minus T divided by T. So this is the second equation. So similarly, this is for what? The load factor. The same thing, loss factor also we need to calculate from the graph. Okay, so the loss factor is equal to average power losses divided by power loss at the peak load. So FLS is equal to PLS average divided by PLS2. Okay, so from the graph we need to calculate the PLS average. So PLS2 T, the same T minus 0 plus PLS divided by capital T minus T divided by T. Okay. So now substituting this equation, so straight away that the FLS is equal to T minus capital T plus PLS1 divided by PLS2 into capital T minus small t divided by capital T, right? So here, what is the conclusion? What is your conclusion? The conclusion in the sense, the both what the load factor and loss factor, both load factor and loss factor, okay, are to be same, okay. But here PLS1 and PLS1 and PLS2 are assumed to be copper losses, which are variable losses, copper losses, which are variable losses. So iron losses are no need to consider because those are the constant losses. Iron losses are constant losses. Here only we need to calculate the variable losses, whereas variable losses in the sense, definitely it is copper losses. Okay. So constant losses is an iron losses are not variable according to the varying, but the variable losses is the copper losses varying according to the load variation. So that the copper losses are always directly proportional to the square root of the load. The copper losses is always directly proportional to the square root of the load. So that's why, what is that? PLS1 directly proportional to P1 square. So PLS1, which is equal to K into P1 square. So PLS2 direction proportional to P2 square. So that PLS2, that is losses, okay, copper losses. So PLS2 is equal to K into, because we need to remove the proportionality. So we can add the constant value that is called K, okay. So the K into P2 square. So now the substituting this equation in the FLS, okay, right? You see here. Yeah. So this value PLS1, PLS2, we need to calculate, we need to substitute this value from this equation. Okay. So what is that? FLS is equal to T divided by T plus P1 divided by P2 square into T minus T divided by T. Now you see that the fifth equation and the second equation. Fifth equation and second equation. What is the fifth equation? FLS is equal to, that is loss factor, which is equal to T divided by T. Okay. So load factor FLD is equal to T divided by T. Okay. Next, plus P1 divided by P2. You see the loss factor here, P1 divided by P2 whole square, right? So into here T minus T divided by T. Here also T minus T divided by T. Okay. Whereas when the peak load is 0, when P1 is equal to 0, peak load is 0, when P1 is equal to 0. If there is no peak load, there is no corresponding peak load losses. Okay. So PLS1 is equal to 0. So this is for the condition FLD is equal to T divided by T, FLS is equal to T divided by T. Okay. Therefore, FLD is equal to T divided by T. Okay. When the case peak load is 0, when peak load is 0, listen carefully, when peak load is 0, so the load factor, which is equal to loss factor. Okay. When peak load is 0, the load factor, which is equal to loss factor. Whenever the peak load is rising, so the peak load is not equal to loss factor. You see that when the peak load time period is calculated the case 2, so that, see, the FLS is equal to square root of, okay, FLS means load factor, okay, load factor, which is equal to the loss factor, square root of loss factor. Okay. When the peak load is, the peak time period is 0. Okay. Now next, when the load is steady state, T is equal to T. When the load is steady state, so FLD is equal to FLS. Okay. So therefore, in 3 cases, we can get the FLD square less than or equal to FLS less than or equal to FLD. Okay. So here FLS is equal to 0.3 into FLD plus 0.7 into FLD square. So we can substitute here the value. So the loss, see the final relation, okay, the final relation is that the relationship between load factor and the loss factor, relationship between the load factor and loss factors are FLS is equal to 0.3 FLD. FLS is equal to 0.3 FLD plus 0.7 into plus 0.7 into FLD square plus 0.7 into FLD square, right? Okay. Now the load growth. Okay. See, once again, I'm going to explain the same concept, right? Please be listen carefully. Why? Because it is very important question, right? So the relationship between load factor and loss factor. Okay. So now we need to consider the load factor. So we have to take the feeder. So in that particular feeder, we have to connect the circuit breaker and as well as the inductance of the conductor, and the final end the load is connected. So assume that the feeder is connected the various types of load. The load, it may be an inductive and capacitive or resistive load. Okay, whereas the resistive load is connected, so assume that the particular load and loss factor characters are graph. Okay, so here the time taken and load and loss are taken in the x-axis and y-axis, so that the first interval, the peak load, okay, which is denoted by P2, and P1, that is a half peak load, it is denoted by P1. Again and again I am telling you, the peak load and half peak load in the sense there is no load, no, not like that. So half peak load in the sense the load is not in the peak condition, the load is there, okay, right? So that's why half peak load, it's a peak load. So the average between these two, we have to denoted by the PAVG, average load. So the same thing, the power losses, PLS2 and PLS1, it's a peak load losses. So our peak load losses, then average peak load losses is PLS average. Okay, so these two we need to calculate the average losses also, right? So now the every load have same corresponding losses. Once again. Yeah. So every losses, every load have some corresponding losses in the above load curve. So the peak load and off peak load having corresponding peak load losses and off peak load losses. So now the load factor formula, which is average load divided by peak load. The load factor, which is equal to average load divided by peak load, right? Okay. Now the average peak load, which is denoted by the P average, the peak load is denoted by the P2. Okay. So from this is equation 1. So now we need to calculate the average. Okay, how to calculate the peak average load? Okay, so the peak average load we need to calculate, so that the ratio between the P1, sorry, P2 and P1, the ratio between the P1 and the P2, we need to add P1 and the P2 divided by the time interval. So that's why P2. So we need to calculate the P2, the time taken, it is maximum time is T, small t, and minimum initial time is 0. So that T minus 0, P2 into T minus 0 plus our peak load. So P1 into plus P1 into, so initial time is small t, the maximum time is capital T. So plus P1 into T minus capital T minus small t, the divided by the total T. Okay, so that is called what? P average. So P average load, which is equal to P2 into small t minus 0 plus P1 into capital T minus small t divided by capital T, right? Fine. So now we can substitute this equation to the first one. Okay, what is the first one? Average, load factor. Okay, so the load factor P average. Okay, we need to calculate. We need to substitute here. So that P FLD in the sense load factor. So the load factor is equal to P2 into small t plus P1 into capital T minus small t divided by T into P2. So rearranging this equation, so FLD is equal to small t divided by capital T plus P1 divided by P2 into capital T minus small t divided by capital T. Okay. So similarly, this is for what? Load factor. Similarly, loss factor also. So the loss factor is equal to average power losses divided by losses at the peak load. Average load losses divided by losses at the peak load. Okay. So FLS is equal to PL average divided by PLS2. Okay. So now PLS average, the same we need to calculate PLS2 into small t minus 0